So for the second problem, we want to show that the curves given by r equals a sine theta and r equals b cosine theta, where a and b are just some numbers larger than 0, intersects at right angles. Great, so then we should first look at these equations and see what they actually look like on a graph. So we have, let's start with r equals a sine theta. Then again, remembering our relations, that is r squared equals x squared plus y squared, and x equals r cosine theta, y equals r sine theta. We can multiply both sides of this equation by r, getting r squared is a r sine theta. And again, r sine theta is going to be y. So this is ay. So r squared is ay. But then we also know that r squared is x squared plus y squared. So r squared is x squared plus y squared is ay. So at the end, this is the relation we're looking at. And therefore, x squared plus y squared minus ay is 0. And for this part, we can just complete the square for y. And therefore, x squared plus y squared minus ay plus a over 2 squared equals a over 2 squared. And therefore, we get x squared minus y minus a over 2 plus y minus a over 2 parentheses squared is a over 2 squared. And this indeed is the equation for our circle. This is a circle with center this is going to be 0 in a over 2. And radius is going to be also a over 2. Great, so let's look at r equals b cosine theta now. So we do the same trick of multiplying both sides by r. So this gives r squared is b r cosine theta. Remembering that r cosine theta is just x, this is bx. And therefore, we get r squared, which is also equal to x squared plus y squared, equals bx. So again, we can complete the square for x to get x squared minus b over 2. Sorry, there should be a square in x here. So this is x minus b over 2 all squared plus y squared is equal to b over 2 squared. I skipped some steps here, but the calculation from this to this step is exactly the same as from here to here. And so, indeed, this is also a circle with center. This is going to be b over 2, 0, and radius is going to be b over 2. So let's see what these look like on a graph. So this is my x and y axis. I have the first circle is center 0 a over 2 with radius a over 2. So let's say this is a over 2. Then my center is equal to my radius, so this circle lives here. And we have another circle with center b over 2 and 0 and radius b over 2. And let's just say my b over 2 is here. Of course, a, b are arbitrary numbers, but just for visualizations, we can just set them to be these. So this is going to be this circle. Great. So this is where they intersect. And I want to show that they intersect at right angles. What does that mean? It means I want to show that the lines that are tangent to the circle at the point of intersection. So let's call this point P, point of intersection P. So I want to show that the tangent lines to the circle at point P are perpendicular. But we know that for a circle, the tangent line at any point is perpendicular also to the radial line from the center to that point. So if these are my tangent lines, we know that they are perpendicular to the radial line from the center to this point. Right? So in order to show that the tangent lines are perpendicular, I just need to show that the radial lines, which is just these two lines, I just need to show that they are perpendicular. But if you remember some geometry from high school, this is quite easy to show, because if you draw this line, this blue line from here to here, we actually get two congruent triangles. Why? Because this line here is length a over 2, and this is also a over 2, because these are just radiuses. And so this line is equal to this line. And the same holds for these two, because they are just both b over 2. And of course, the middle line is equal as well. And therefore, this is a case of SSS triangle congruence. So congruent triangles have the same angles here and there. And because we know the y and x axes, they intersect at right angles, so this angle must be equal to this angle. And so the radial lines intersect at right angles. And therefore, my tangent lines also. And this completes the proof.